Hello everyone, myself Professor Rakesh Patil from the Department of Civil Engineering, KLS VDIT Halyard. I welcome you to the lecture series on Engineering Geology. The subject code is 18CV36, third semester. Today we are going to discuss about module number 2, lecture number 11. Before starting with today's class, I would like to just brush up the things which we have discussed in last class. In last class, we have discussed the minerals and their importance in construction, then materials which are used for the construction. In that, we have discussed the quartz varieties, mica varieties, feldspar group, and some of the indirect minerals which are useful for the construction, like iron, aluminium, bauxite, means ore forming in minerals. In today's class, we are going to discuss petrology, that is study of the rocks. As we all know, the rocks are plays very important role in the construction field. So as a civil engineers, we are supposed to understand which type of rocks will be used for the construction. Not only for the construction, so in today's class, we are going to discuss about the petrology, which is study of the rocks. As we all know, it is very essential to understand the behavior of the rocks before using them into the construction field. Like in today's class, we are going to discuss which type of rock will be used for the particular regions. Like say for example, in foundation, what type of rock will be used? For the flooring, what type of the rocks will be used? That all we are going to discuss in the petrology topic. Petrology is nothing but it's a study of rocks, and rock is defined as it's nothing but it's aggregation of the two or more than two minerals. In first module, we have discussed the mineral which are single substance. In today's class, we are going to discuss. In second module, we are going to discuss the aggregation of the minerals. In previous module, we have discussed the single substance. In today's class, aggregation of the substance, that is rocks. In today's class, we are going to cover the introduction part of the petrology and geological classification of rocks, common textures. Textures are very useful to understand the color behavior, which is useful for the decorative purpose. Then structure of the rocks. Then we are going to discuss the rock cycle, which type of rocks are there and their formations. Then their importance in the civil engineering. Petrology is it's nothing but it's a branch of geology that deals with the rocks and the condition in which rock the substance or the deposition may have been taken place. The subject matter of the petrology consists of the origin, association, occurrence, minerals, composition, chemical composition, texture, structure, physical property of the rock. Whereas petrography deals with the descriptive part of the rocks, and petrogenic deals with the mode of formation of a rock. These two together make up the petrology. In simple words, as a civil engineers, we are supposed to understand what type of rocks are used for the in the particular regions, and all the types of rocks are not available for the construction. It is varies area to area wise. Like if you belongs to the Karnataka, there the basic igneous rocks will be available, whereas if you travel towards the Maharashtra, in that a very primary rocks are available, that is basalt rocks. The difference between basalt and granite will be seen in next upcoming slides. These rocks are classified into three types. As we all know, igneous rock. Igneous rock is nothing but it's a hot gaseous material, hot liquid material which is cooled down by the magma. And sedimentary rock, metamorphic rock. Igneous rocks belongs to the primary rocks which are originated from the magma or lava, whereas sedimentary rocks are originated from the igneous rock or metamorphic rock by means of weathering process. When igneous rocks break down, it gives rise to a secondary rock, that is sedimentary rock. Then third one is metamorphic rock. Metamorphic rocks are nothing but it's a change in a shape and size. When igneous rocks, metamorphic rock is also secondary rock which derives from the igneous or sedimentary rocks. That we will discuss in the rock cycle. Just as a civil engineers, we are supposed to understand the geological classifications of a rock. It is the rocks are classified in various ways based on a different principles such as physical, chemical, and geological classification. Among the different classifications, geological classifications and rock classifications are most proper because grouping of a rocks is more logic, less ambitious, orderly, comprehensive. The geological classification of a rock is based on the mode of origin, and they are igneous, which are made up of magma or lava, sedimentary, which are made up of a weathering process, metamorphic, which are made up of a change of a primary existing rocks, change of a shape and size. This is the how classification chart is look like. In rock, we have seen the three types of rocks: igneous, sedimentary rock, and metamorphic. In igneous also there are two classifications are there, that is namely extrusive, intrusive. Extrusive and intrusive. Extrusive means which are forming above the surface, like when magma comes out, lava forms on the earth surface. When lava cools down, it will give rise to a extrusive rock. Example, basalt, which you are using for the aggregates for the construction, that is called as basalt rocks. Then intrusive rocks, which are cooling and crystallizing below the earth crust. Example, granites. In basalt and granite, there is the difference is granite is a light colored one, basalt is a dark colored one. Dark color because it is coming in the atmospheric, it is coming in the contact with the atmosphere. That's why the basalt rock will be look like a dark in color. In granite, the crystallization takes place in as a slow process. That's why the grain sizes are very larger compared with the basalts. Where basalt is the fine material, granite is the granites will be having the more granulars. In sedimentary rocks, it is classified into two types: clastic and chemical. Basically, we call it as a clastic and non-clastic. Clastic means which are processed by the physical changes or a physical weathering, whereas chemical is nothing but it's a chemical weathering. When igneous rocks breakdowns, it comes in a contact with the water, and due to the presence of water and presence of the minerals, both segregations which brings the chemicals out. Example, limestone. For a clastic, sandstone. In sedimentary rock, we have two types: clastic and non-clastic. Non-clastic are called as chemical. Clastic, for example, is sandstone. And for the non-clastic, example is limestone. In metamorphic rock, again we have two types of rocks: foliated and non-foliated. Foliated means which rocks will be having a more or less circular in a manner, in a matter. Whereas non-foliated, those are foliation. The minerals will be non-foliation will be there. Means irregular shapes will be there. That is marble. For foliated example is slate, non-foliated marble. Now, first one, igneous rock. The type of rocks is in the first one is igneous rocks. These are formed by cooling or solidification of either lava or magma. Based on the mode of occurrence, igneous rocks are also classified into two types: extrusive and intrusive. Based on a silica, there is another major formation for the igneous rock is silica. Based on the silica, the igneous rocks are again classified into 4 types. If you have the more than 60% of silica, then it is called as felsic rock. If you have a 50 to 60 percentage of silica, then it is called as intermediate igneous rock. Then if you have a 40 to 50% of silica means nothing but it's a quartz variety is present. Then 40 to 50% is mafic igneous rock. Then less than 40% is there, then means it is called as ultramafic igneous rock. For felsic, example is granite. For ultramafic, the example is basalt. These are primary rocks, most abundant rocks in the earth crust. These formed in at the very high temperature and pressure condition directly as a result of a solidification of a magma or lava. What is magma? Magma is nothing but it is the term magma is applied when the melt is underground. It is a hot gaseous material or a hot molten material. Lava, it is the melt when it melt when it reaches the earth's surface and flows over the earth is called as lava. For magma, example is granite rock. For lava, example is basalt rock. Granite are used for the foundation purpose, whereas basalt rocks are used for the aggregates. So what is the intrusive rocks? Intrusive rocks are formed from the magma that cools and solidifies within the crust of a planet surrounded by pre-existing rocks called as country rock. The magma cools very slow, and as a result these rocks are coarse grained. The mineral grains in such rocks can be generally identified by the naked eyes. Example is granites. You can see in granite the coarse grain will be there. You can observe black color and white color and pink color easily. You can see in this. In granite you can differentiate between the different colors. Another dolorite, you can see the patches of the colors. For the intrusive rocks, it is most probably it is combined and compacted one. You can see in this. Basalt is the intrusive rock, whereas dolorite is the extrusive rock. Here you can differentiate between the colors, but here you can't differentiate between the colors. This is extrusive rock and this is intrusive rock, but both are called as igneous rock. Both are formed from the magma or lava. This is from magma and this is from lava. So what type of textures we can observe on the rocks? Degree of crystallinity, granularity and shape of the crystals. You can easily observe these all 3 types of textures on the rocks. Granularity is a very important concept in the civil engineering, because when you have a good type of granulars, then automatically that particular material will be used for the decoration purpose. Common textures found in igneous rocks are vesicular structures, amygdaloid structures, columnar structures, sheet type structure, flow structure and pillow lavas. You can observe all the types of material in the particular earth crust. These are called as vesicular structures because it is running parallel with the rock materials. Amygdaloids, these are called amygdaloids. These are the reasons for forming the ore minerals. Then columnar structures, these vertical layer will be called as columnar structures. Column like shapes will be there. For example, if you go to the St. Mary's Island, there the columnar structures you can identify. Then sheet like structure. Then pillow lavas. Next one is sedimentary rock. Sedimentary rocks are those which are formed by the accumulation, compaction and consolidation of a sediments. The sediments are the particles produced from the disintegration of a pre-existing rocks. It may be igneous or it may be metamorphic. These are also described as secondary rock. They are derived from the consolidate of sediments. The sedimentary rocks includes variety of rocks formed by accumulation, compaction and consolidation of the sediments or even organic materials like fossils. These rocks are known to cover as much as 70% of the surface of land area, but at the depth wise these sedimentary rocks disappears. For the process of the sedimentary rock, it may be the weathering or erosion, transportation, deposition and lithification. So these are called as, this is how sedimentary rocks looks like. Layer by layer formations and granularity will be more in that. But strength wise, if you compare with the igneous rock, these rocks are not will be given as strength as the igneous rocks, because it is unconsolidated rock layers which are formed due to the weathering process. Sediments are the products of the weathering. Since these are secondary material that is derived from the pre-existing rock, the rocks are formed out of them are called sedimentary or secondary rocks. The origin of sedimentary rock is totally related to the weathering influence of the rocks. You can see in this particular diagram. Firstly, there will be a presence of rock will be there. Then after a long time, the rock get weathered. Then weathering start eroding of the sediments, end up with meeting to the water. Then you can see the yellow layer here, how sediments or depositions will be there. Then again second layer will come and deposit on the above layer, below layer. Then strata forms. You can see the strata here. Then cementation takes place. Cementation is nothing but as a compactions. Common structures found in sedimentary rocks are primary structures are formed during deposition. Secondary structures formed after depositions. Next one is metamorphic rock. Metamorphism is literally means change. The change in a pre-existing rock under the influence of a temperature, pressure and chemical active fluids, that is like water. The metamorphic rocks are formed from igneous rocks are called as orthometamorphic rocks, and these are formed from the sedimentary rocks are called as parametamorphic rocks. Metamorphic rocks are also called as which are formed by the metamorphism. The metamorphism is the process by which changes are brought within the pre-existing rocks by the heat or a temperature or a chemical active fluids. Many changes may either in their structure or chemical composition. That end product formed due to this process is called as metamorphic rocks. For this metamorphic rock, pre-existing rocks are igneous rock and sedimentary rocks. Common structures in igneous rocks are gneiss, schistose and granulose. Texture is defined as the size from the oriented of a class or minerals in a rock called it is texture. Texture is a small scale property of a rock but determines many of its large scale properties such as the density, porosity or permeability. So this is rock cycle. First, igneous rock. From igneous rock, either it may changes to the sedimentary rock or it may changes to the metamorphic rock. Then from sedimentary rock, either it may go to the metamorphic rock or it may again go to the igneous rock. From metamorphic rock, either it may changes to the igneous rock or a lava or a sedimentary rock. So that's why igneous is the primary rock, sedimentary and metamorphic rocks are the secondary rock. As a civil engineering point of view, Petrology is very important from the civil engineering point of view, as it provides a proper concept of and a logical basis for the interpreting the physical property of a rock, the study of a texture, structure, mineral composition, chemical composition, etc. gives all necessary details regarding the strength, durability, color, appearance, workability, etc. These inherent characters of rocks are chief concern of for civil engineering projects. You can see, for example, best example for the for a rock for a civil engineering point of view is for from the igneous rock, granite and basalt, sedimentary rock, sandstone and limestone. For metamorphic rock, marble and gneiss rocks. For example, granite, like a rock being hard, competent, durable and free from weak clay, are suitable for the foundation purpose. Stones like Kadapa slab and Shadab type limestones are suitable for the flooring, roofing purpose. Marble by virtue of its attractiveness, color and softness is the most sought after for face work, statue making, decorative and other sculpture work. Sandstone being easily workable, can be neatly dressed, and hence it is suitable for the construction of walls. Many of the sandstones are crushed and prepared the bricks, or some clay materials can be used for the other type of bricks. Thus, different kind of rocks suit for different purpose by virtue of their special physical property, which are inherent and characteristic to them. These details must be known as to make the best use of available rock at the construction sites. As you can see in this particular diagram, the different types of colors and variations and textures can be used for the civil engineering purpose. Thank you very much. That's all from the today's class. In next class, we will be discussing the internal intrusive igneous rocks and their importance, and most important is how to construct tunnels when we have intrusive igneous rocks in that particular regions. We will discuss in next class. Thank you very much.